Wait. What?
No, Mohammed, we're starting
What's your
here.
counseling?
All right.
You might as well
Rein
start
it
over
in.
again.
No, let's go. Part 2, all
This
right?
is going to be in the video.
Part 2, take 2.
Action. All right. This is it. Number 26. Johnny wants to find the equation of a circle with the center at 3, -4, and a radius of 7. Let's just write the equation. It's going to be x, it's a +3, so what do I write? Good. Plus y is a -4, so we do
+4.
Yay! And now the radius is 7, so we don't write 7 squared. We finish strong. It's going to be 49. That's your equation. Done. Now, we've done this problem before. Alright.
Now we have to take a 3.
I know it's tough, buddy, but okay. This is saying, let xy be any point on the circle. Then the horizontal distance from xy, just some random point, to the center. Horizontal, that's x. All that you're going to write here is x minus 3. That's it. All right? The vertical distance, so now we're talking y's, to the center is going to be y plus 4. You just write that. The total distance from this random point to the center is the radius of the circle, which is 7. Guys, we've talked about this before. If we have this going on, if we have a circle, blah, 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 and they're talking about this, and the radius is 7, that's not this circle, by the way, that's just a random one. And I want to figure out vertical distance or horizontal distance. We are talking about the Pythagorean theorem, always. All right? So that's it. Good old Pythag. All right? Don't get too hung up on the rest of it. Questions? Great. All right. I love this one. Alejandro, cut a circle with circumference C and radius R into 8 congruent sectors. We have seen this before also. And he used them to make the figure shown. He noticed that the figure was very close to the shape of a parallelogram. Select all the statements that apply to the figure. All right. You've got to go through because it says select all. So in this case, for the first one, the height of the parallelogram is approximately equal to the circle's diameter. Is that true?
No.
No. Actually, what is the height equal to?
The height.
In regard to the circle, someone said it. The radius. Excellent. Think about that. This here is all those points are technically like the center of the circle. Remember? It's like not bad. Just like if you took this thing and just okay? So that one's out. The area of the parallelogram is approximately 1/2 the circumference times the radius. Let's think about this. If we are talking just about this here on the bottom, like the base of the parallelogram, is that not equal to 1/2 of the circumference? It's literally like we took that circle and
Take 4.
it's literally like you took this circle and you took all these pieces and you stacked them like this. Yeah? So the circumference of the circle is this and this. That is the entire circumference, which means the base of the parallelogram is equal to 1/2 of the circumference. This is 1/2, this is the other 1/2. So if we're talking about finding the area of the parallelogram, what's your formula for area of a parallelogram? Base times height. Good. So in this case, the base is equal to 1/2 the circumference, so that looks good. And we've already discussed this. The height is what?
The radius.
The radius. So yeah, that one checks. The arc length of the parallelogram, sorry, I don't know why I just said arc length. the length of the parallelogram is approximately equal to the circle's circumference. Is that true? The length
Oh,
of
yes.
Yes.
the length?
Like,
Yeah.
isn't that only?
No, it's half. So no, that one's out. The radius of the circle is approximately equal to the height of the parallelogram. Yeah, we talked about that, right? The area of the parallelogram is approximately, now I really, really like this one. Because all that they did here, the area, so now we're talking about all of it. What they have here, that's our formula for sector area. Think about it. But they did 45 over 360 times pi r squared times 8. If I start here and go all the way around, that's 360, yeah? How many of them do we have? 8. So divide that by 8. Let's get the measure of 1. You shouldn't need a calculator for this, guys. 8 goes into 32 4 times with the remainder of 2. Yeah? So in this case, this is showing, bless you. This right here represents this 45 over 360 times pi r squared. That represents the area of one of those, or one of these, yeah? Okay, how many of them do we have? 8. Is that true? Absolutely. That's a really, really good way to look at it. Not a good way, a crazy way to look at it. Bless you. Bless you, my child. Question on this?
So if it didn't have the 8, it would be wrong.
If it didn't have the 8, that is a really good question. If it didn't have the multiplying by 8, it would just mean the area of one of those. By the way, on another note, I want you to remember the sprinkler problem too. Never forget that. Yes, Sean, go ahead.
For the third one where it says the length of the parallelogram is, how is that not true? Because aren't you just
But the length of it is like the base of it, right? The circumference of this is this plus this. Are we good? Remember when I just took that cone and did the wheel?
What would the perimeter be equal to?
What, honey?
What would the perimeter be equal to?
Not the perimeter though. This and this, not that. Because what this, that's actually a really good question. What this here represents, that's coming from the inside of the circle. That is actually the radius. All of these are radii. Everything in the center. Because it's literally like we took it, we cut it. That's why everything on top is curved and everything on the bottom is curved. Okay?